Alright guys, we are going to go through today the 2024 Paper 1 MCQ for Pure Chemistry O Levels. So let's look at the first question, shall we? So they say two experiments measure the volume of gas produced during the first 30 seconds of a reaction. The method of the gas collection is changed, but all other conditions are kept the same. So we are looking at a reaction of metal carbonate with dilute acid. Okay, so we can see that from the table, right? Experiment 1, you have 28 cm cube collected after 30 seconds. Experiment 2, you have slightly more, 32 cm cube. So they are asking which statement explain why the volume of gas produced after 30 seconds is different in the two experiments. Okay, so option A, they say volume of gas collected in experiment 2 included some air. Okay, so this is not the reason because anyway, there will be some air in this area which will get pushed out anyway. Okay, so by right, the amount of air that is displaced should be the same as experiment 1. Okay, so that doesn't explain why there is additional 4 cm cube of additional gas was produced. Okay, so option A doesn't really explain it. Option B, the gas produced in reaction is partially soluble. Okay, I would think that when they say partially soluble, is soluble here. Okay, in the solvent, presumably water. Okay, so if it's partially soluble, then it will make sense that experiment 1, since it passes through this liquid here, right? Some of it will dissolve in this liquid, presumably water. Okay, and will give us a lesser volume of gas produced right here at the end. Okay, so this option actually makes sense. Okay, option C, the reaction in experiment 1 is not complete. The conditions are the same, so they're both going to take 30 seconds. If reaction in experiment 1 is not complete, so too is the reaction in experiment 2. Okay, which still doesn't explain why is the volume of gas collected different. Okay, so this option is incorrect. So we're going to rule this out. D, there's a leak in the apparatus. No, if there is a leak in the apparatus for 2, there could also have been a leak in the apparatus for 1 as well. So we are not going to accept this reason. So the only reason, right, for question 1, the only logical one should be option B. Okay, so for the first question, we are just going to go with option B. Alright guys, let's move on to question 2. Okay, so this question is again about a gas collection. So there's a reaction between lead-2 oxide and carbon monoxide, which I've written out for you the equations. So there is a reduction of the metal oxide back to the metal itself, and an acidic CO2 is then produced. So they are saying which of the setup, right, with the correct reagent will allow the scientists to identify the gaseous product and prevent carbon monoxide from entering the atmosphere. So if you look at the setup, right, there are 3 parts that you need to look at, since the first part is more or less the same for every setup. Okay, so the first thing you need to look at is the reagent here, which is supposed to capture acidic CO2, carbon dioxide. So the first setup, the already concentrated sulfuric acid is acidic, same as CO2, so it will not capture and absorb, neutralize your acidic CO2. Okay, so the first option is out. The second option, this part here, the gas is not made to go through the lime water, so the setup is also incorrect. Okay, the third setup, everything is done well. You have the correct reagent. You actually force the gas produced to go through this reagent. And lastly, your tube extends into a dead end inverted measuring cylinder. Okay, so this is the best setup. It will identify the gaseous product and prevent excess CO2 from entering atmosphere. Okay, so our answer is actually C. Okay, the last option, why is it wrong? Because then the bubbles will come out from here and go into the surrounding, okay, which is not what we want. So D is also out. Okay, so for question 2, our answer is C. Alright guys, let's look on at question 3, a solid mixture containing magnesium sulfate and sand. Which sequence allow pure magnesium sulfate crystals to be separated from the solid mixture? So if you look at the two things that we are given, sand and magnesium sulfate, you realize that magnesium sulfate is actually soluble. It's a soluble ionic salt, and then sand, which is mostly made out of silicon dioxide, is not soluble in water. Okay, so one soluble, one not soluble. You just actually first step need to add the water, and then you don't have to heat it. You don't have to heat it. You also shouldn't evaporate. You should immediately filter it so that your residue, right? Your residue, you get sand, and then your filtrate is where your magnesium sulfate will be. You evaporate it to dryness and you'll get the magnesium sulfate crystals. All right, so our answer should be A. Okay, B is not accepted also because you haven't gotten rid of the sand. Okay. Okay, now let's look at question 4, right? We have 4 different mixture W, X, Y, Z, which needs to be separated. The first is solid lead-2 chloride and lead-2 nitrate. Okay, X is your lubricating oil and your water. Y is ethanol and water. Z is iodine and sand. Okay, so they list out possible methods for separation, which is the suitable method. So I've gone ahead to actually label them. For sublimation, it is very obvious that iodine is the one that you can get to vaporize immediately, and what's left will be your sand. Okay, using a separating funnel is to separate two immiscible liquid, which will be your lubricating oil and water. And then when you add water followed by filtration, that will help you to separate insoluble lead-2 chloride from soluble lead-2 nitrate. Okay, the last one, fractional distillation, right, is to help us separate miscible liquids, ethanol and water, which has quite similar boiling point. Okay, so fractional distillation will help us to separate ethanol and water. Okay, so let's look at which option tallies with what we said. Okay, number 1, sublimation. So these 3 are okay. Number 2, X, just these 2. 3, W is just this. So our option, we actually have no choice. It's just D. Okay, D will be our answer here. Alright guys, let's look at question 5. So we have 3 samples of colorless compound X, Y, and Z, which are investigated using paper chromatography. Okay, so we have this chromatogram with a start line. Which statement about this investigation is correct? Locating agent is used. Actually, yes, this is gonna be true because they are colorless. You will need a locating agent, okay, to identify all these spots that you see on the paper chromatogram. Okay, X contains only one compound. You can see that that is not true. It actually has 2. The chromatogram for Z may be used to investigate its percentage purity. We won't know how much of each compound that it has. So this will be wrong because then you cannot know how many moles does it have. How do you calculate the percentage purity? Okay, the RF value of one of the components in Y, they say one of the components is half the RF value of one of the components in X. That's not true actually. If you look at it, the best case scenario is where you have this this spot here is the same RF value. there's no RF value in Y that is like twice the RF value of the components in X. So this statement is simply not correct. So our answer here is A. Okay, so this question 6 is like one of the easiest question I've seen so far. Which statement is correct? If you look at statement A, fixed shape and volume, that's a solid. Okay, B, they are close together and can slide past each other. This is okay. Particles in a liquid are in a regular structure. This is a solid. Particles in a liquid vibrate about in a fixed position. Also talking about a solid. Okay, so our answer here, very straightforward, is B. Alright guys, let's look at the question 7. So they say this is the typical experiment where you have HCl at one end and concentrated NH3 at the other end. So they are diffusing and then they meet and form a white ring of ammonium chloride. Okay, so they say experiment 1, you use the normal hydrogen. Experiment 2, you're going to use deuterium, which is the heavier uh, isotope for hydrogen. Okay, which diagram shows the position of the white ring correctly? Okay, so first of all, right, if you look at the experiment, you need to recognize that your two rings, right, should form closer to HCl because HCl move relatively slower because it's heavier, about 36.5 mR compared to NH3, which is about 17. Okay, so NH3, right, between A and B, NH3 should actually diffuse faster, so the position should lie a little bit further away, okay, as compared to deuterium. Okay, so option A should be correct. Our answer here is A rather than B. Okay, so for question 8, you will need to probably refer to your periodic table. They are asking which statement is correct. All three ions contain the same number of electrons. So if you look at the periodic table, right, you realize that sulfur 2 minus would have 18 electrons, chloride also 18, calcium 2 plus also 18. So A is actually our correct answer. If B, it contains the same number of neutron, let's see. Okay, let's pick sulfur, which has 16 neutron. Compare that with calcium, which has 20 neutrons. Okay, so this is wrong already. Fundamentally, C will be wrong because all the elements have different number of protons. So that is wrong. D is also wrong because calcium is at the period 4. Okay, so our answer here is A for question 8. Okay, question 9, magnesium and oxygen react together to produce magnesium oxide. So actually, magnesium oxide, the formula is just MgO. Okay, 2 electrons are lost from magnesium to go to 1 atom of oxygen. Okay, so both will go to 1 atom of oxygen, which means that our answer is C lah. I mean, it's quite obvious that C is the only one with the correct formula and the correct direction of the electron from metal to non-metal. Okay, question 10, which row shows the number of electron used in covalent bonding? Covalent bonding. Okay, so let's draw out the molecules here. Ammonia. Here 6 is A. It is wrong. Carbon dioxide don't need to draw because they are both the same. Nitrogen, yes. Nitrogen we need to draw. Nitrogen 1, 2, 3. Also 6. Okay, so our answer is actually just B. Okay, let's check it out with oxygen. Yeah, so a double bond. So yes, confirm B is our answer. Okay, so question 11, which statement about metals are correct? The first statement is wrong because an alloy is a metal made by combining two metals, not metal and one other element. Second statement, they are good conductors not because of the mobility of the electron, but because of the delocalized C of electrons. Okay, so ions is not correct. That leaves us with number 3, which is correct. And our answer here is D. Alright, for question 12, they say that boron nitride, it has the same structure as diamond. Okay, and they have very similar properties. So a student suggests 3 possible uses. First use, electric conductor, no, because diamond is not a conductor. So we're going to cross that out. As an abrasive, where extreme hardness is required, diamond is extremely hard, yes. To make cutting tools that will cut hard steel, yes. Sure. Yeah, so our option is D only. Okay, so let's look at question 13. You have iron 3 chloride, reacting with sodium ethane dioate, a precipitate of iron 3. We have iron 3 plus and ethane dioate C2O42 minus is formed. What is the formula? Okay, so you're going to crisscross this. You need 2 of iron and 3 of the ethane dioate so that you have a neutral compound. Okay, so our answer here is C. Alright, everybody, let's look on at question 14. Question 14, we have 10 grams of alcohol containing twice as much oxygen as it does hydrogen. Percentage by mass of hydrogen is 13.33%. What's the empirical formula? Okay, so this is the normal table that we do. So we get all the percentages by mass. The way that I get carbon, right, is I just add up percentage of hydrogen and oxygen, which is twice that of hydrogen. Just add them up. That's about 40%. Carbon, you get 60%. Okay, so just take that percentage by mass, go and divide by the AR of the elements respectively, and then you will get 5, 13.33, 1.67. After this, you will just divide by the lowest common multiple, which is 1.667, and you will get your empirical formula ratio, which is 381. The only answer that tallies with this is option B. Okay, so for question 15, it's just a more concept question. We have 4.29 grams of XO2 reacting with carbon monoxide. So this is like a reduction. And we are told that there is 862 cm cube of CO2 being produced. This, if you go and divide by 24,000, which is the molar volume at RTP, you will get 0.0359 moles. You just take the mass, divide by this number of moles, because these two number of moles will be the same, yeah? 1:1. So you get the MR of the whole oxide, which is 119. This is not yet the answer, so don't go pick B as your answer. You will still need to minus away 32, which is the part that is contributed by oxygen, so that you get the final AR, which is 87.5. The closest is SR. Okay, so our answer here is A. Alright guys, so question 16. In a reaction between 23 grams of ethanol and excess HBr, the mass of bromoethane obtained is 27 grams. So I went ahead and I divided by their respective MRs, and I got 0.5, 0.2477. You just take 0.2477, divide by the theoretical yield. So the actual yield over theoretical yield. This is the actual and this is the theoretical. Okay, so multiply by 100%, you will get close to 50%. So our answer here should be B. Alright, so for question 17, you have sodium sulfate and also lead nitrate mixed together. So what is the salt that is produced? I've written them down. Sodium nitrate, which is soluble, lead sulfate, which is insoluble. So one soluble, one insoluble. Our answer here is All right, guys. So question 18, they have 4 pairs of solution. They say which row identify the pair that can be mixed together to produce a solid salt by precipitation, and which pair can produce a salt by titration followed by crystallization. Okay, so I've highlighted and color coded. It actually took me a while to understand what this question is asking for. Basically, it just says that, okay, for precipitation, right, you just need to look for a insoluble salt. So if you look at all the equations, the only insoluble salt present is from the second pair, which will leave us with C and D. Okay, and then the salt that can be formed by titration is your number 3, the third pair, ethanoate, potassium ethanoate. So this salt can be formed by titration and then followed by crystallization. Okay, so our answer here should be C. All right, let's look at question 9. Question 9, we have a QA, cation and anion test. So you have zinc sulfate, right? Your zinc will react with both ammonia as well as sodium hydroxide, and forming a white PPT which dissolves in excess. So both C and D are accurate. For the anion, right, only barium will form a white PPT with sulfate. All right, so D is our answer here for question 19. Okay, so question 20 is a fairly easy, straightforward question. They are asking what is the minimum number of items that we can use to identify 4 gases. So if you look at the ammonia, chlorine, right, basically you can just use a red litmus paper to test for both ammonia and chlorine. And for hydrogen and oxygen, you just need a wooden splint. Okay, so the answer here should be A. You only need 2. Okay, so question 21, which reactions are redox reaction? Basically, we just need to look out for those where you have elements and change to a compound. So option 2 and 4, you have zinc and iron changing to their respective compounds. So our answer here is C. All right, so let's look at question 22, sorry. Excess Ki is reacted with KMnO4 acidified. What is the final color? So the keyword here is we have excess of your I minus. Nobody cares about the potassium. It's being oxidized to brown I2. So manganate, although it is purple in color, right? But because I minus is in excess, so basically all of this will be reacted off to give you colorless Mn2 plus. So if Mn2 plus is going to be colorless and then your I2 is brown, your final color of the reaction mixture should be A, brown. Okay, so our answer here is A. Alright, so let's look at question 23. This is fairly straightforward. You have molten calcium chloride electrolysis. Okay, so a positive electrode is your anode. So the anions present is Cl minus, definitely not Cl2 minus because that's the wrong charge. So A and B possible. For the negative electrode, which is the where reduction took place, the cathode, calcium is 2 plus. So answer here very straightforward. It's just B. Okay, so question 24, 3 electrolysis experiment are described. So they say in which of these experiment is the same element oxidized at one of the electrode and reduced at the other. So if you look at the 3 options, right, 1 is just electrolysis of water. 2, when you have concentrated sodium chloride, the chloride is going to be preferentially discharged. And for 3, when you have reactive electrodes, right, then obviously your copper is going to preferentially oxidize as well as reduce at the cathode. Okay, so the third statement is the only one that is correct. So our answer here is D. Okay, let's look at question 25. You have a simple cell. Which statement is correct? Okay, so if you look at the reactivity, right, zinc is going to be oxidized and copper is going to be reduced, okay, on the left side. Okay, so anions flow from zinc to, no, it's not anion, it's electron flowing. So the electron will go this way. Electrons flow from copper to, okay, this is also wrong. Ionic equation is the oxidation of copper. This is wrong. Zinc is oxidized. Absolutely correct. Our answer here is D. Alright, so for question 26, we have 4 elements Q, R, S, T. Letters are not their symbols, yes. So by the way, I've taken the liberty to label the group number so that we roughly have an idea what are these elements. Two of these elements form a compound with the formula X3Y2. So when you do the crisscross method, right, you realize that X is going to be from group 2. So group 2, only Q is from group 2. So answer is only A and B. And then you will need Y to be from like group 15. Group 15. Okay, group 15 is S. Okay, so our answer here is B. Okay, so question 27 is about reactivity on metals. So it says that X and Y both floats on water and reacts rapidly, producing effervescence, just that Y reacts even more rapidly than X. Okay, and Z sinks in water, reacts very slowly. What's the order of increasing melting points? So the concept that's tested here, right, is that elements that react more vigorously with water are more reactive and have lower melting points. Okay, then elements that sinks in water, they are usually denser and have higher melting point. Okay, so going by this theory, right, then our most reactive is your Y. So the only option that starts with Y is actually B, which is our answer here. Okay, so for question 28, we have mercury sulfide and copper sulfide, which is heated to extract the pure metal. Mercury sulfide only heat to 300, you will get a pure metal, but copper sulfide requires 1200 degrees Celsius. Which two deduction can be made about reactivity of mercury? Okay, so we're just going to compare mercury as compared to copper, right? If you look at the data 300 versus 1002, it means that mercury sulfide needs lower extraction temperature, which means that mercury is less reactive than copper. Okay, mercury less reactive than copper, which means that mercury cannot displace copper from its compound. All right, so C and D is okay. If mercury is less reactive than copper, right, since copper also doesn't really react with acid, then what more mercury? Okay, so mercury also does not react with dilute HCl. Our answer here is D. Right, for question 29, sample X contains 0.05 mole of chlorine gas. Okay, so we need to realize our chlorine gas is actually Cl2, which means that there are actually 2 moles of chlorine atom. Okay, so we need to be careful of that. Sample Y contains 0.1 moles of CCl4, which means that is 4 chlorine atoms. Okay, so what does this mean? If 0.05 times 2, that will give you a grand total of 0.1 mole of chlorine atoms. Okay, so if there's 4, means that 0.1 times 4 is 0.4 moles of chlorine atoms. Okay, so you have 0.1, 0.4, 0.1 will be C and D is okay. 0.4 would be yeah, 0.4. Okay, so our answer here should be D. Okay, so for question 30, we have a combustion of hydrogen with oxygen. A student makes four statements. So if you look at the four statement, right, the first statement says energy released when 4 OH bond form is more than the energy absorbed. So this is describing the exothermic reactions. This is absolutely correct. The reaction have a positive delta H. That's not true. Positive delta H is for endothermic reactions. Temperature of the surrounding increases. Yes, because something is being burnt. The diagram shows energy changes. No. So if you want to go up only, you should form atoms here instead of the water molecule. Water is more stable, so it should be down here. You are missing one more. So on top there, right, you should get 4 hydrogen plus 2 oxygen. And then the 2 H2O should be here below. Alright, so which two statements are correct? 1 and 3. So our answer here should be A. Okay, so for this question, right, each of these grids here, right, we have to take note. Okay, so the activation energy of the backward reaction has the same value of the activation energy of the enthalpy change of reaction of the backward reaction, but the opposite sign. This is actually correct. At first glance, I thought it was wrong, but there is actually two grids going up and two grids going down. So the same value but different signs. So A is correct. For B, right, activation energy of the forward reaction, which is the blue arrow, has the same value as enthalpy change of the backward reaction, which is the green highlighted. It is not correct. Okay, activation energy of the forward is 4 times that of the activation of the backward. No, it's just twice. Okay, it's just 2 times. Right, so this is wrong. Overall energy change of the forward and backward have the same value. No, the enthalpy change of the forward is positive 2 and the backward is negative 2. Okay, the sign is different. Okay, so wrong. So our answer here should be A. Okay, so for question 32, catalysts provide alternative pathway for the reaction. Which rule for the catalyzed reaction is correct? Activation energy is lower, yes. Enthalpy change stays the same. Alright, so our answer here should be A. Okay, so question 23 is on fractionating column to separate fractions in the crude oil. Which trend is indicated by the arrow? So this is the arrow over here. So if you look at it, right, and you look at the four statements, boiling point, yes, it decreases as you go up the column, but the viscosity actually should also decrease because its viscosity means the stickiness of it, which means the intermolecular forces. So intermolecular forces are actually greater lower the column. So viscosity actually decreases going up the column. So A is wrong. B, the size of the molecule in the fractions going up the column actually decreases. So B is also wrong. C is okay. As you go up the column, the size of the molecule and temperature both decreases. C is our answer. Why is D wrong? Temperature and the boiling point both increase. As you go up, right, the boiling point of the molecule actually decreases because they are getting smaller in size. Okay, so option D is also wrong. Answer here is C. Okay, so for question 34, they're saying how many different isomers with 2 chlorine substituted can be formed. So you can substitute both chlorine on the first carbon, that will be 1,1 dichloro, and then you have 1,2. And then of course you cannot have 2,2 because there's only one hydrogen. And then you can have 1,3. Okay, so since these two carbon are the same, you can only have like 1, 1, 1, 2, and 1, 3. Okay, so our answer here is B. Okay, so question 35. Compound X reacts with steam to form compound Y. Compound Y react with oxidizing agent manganate to form compound Z. Compound Y and Z react together to form the ester ethyl ethanoate. So ethyl ethanoate, you can work backwards. This is the ester. Ester must react with carboxylic acid and alcohol with a concentrated sulfuric acid as catalyst. Yeah. So working backwards from here, right? What reacts with steam to form alcohol is your alkenes, C double bond C. Okay, so they are asking what is the empirical formula of compound X, which is the alkene. As you know, alkenes have a formula of CnH2n. All right, so the only option that's available is A. Okay, so for question 36, ethanol is made by addition reaction. So this addition reaction, you need a catalyst, yeah, phosphoric acid, concentrated phosphoric acid. Can also be made by fermentation of glucose. This you will need yeast. Which reaction require a catalyst to be present? Actually, both reaction require a catalyst. One is a enzyme, the other is like a concentrated phosphoric acid. So answer here should be A. 37. Statins are compound used in some medicine. An example of statin is shown. Which part of the structure shows the functional group found in carboxylic acid? So it's A lah, right? Because this is the carboxylic acid. B is alcohol, OH. C is ester, double bond O, single bond O. D is alkenes. Right? So our answer here is A. Okay, question 38. Partial structure of two polymer P and Q are shown. Which type of polymerization produces this polymer? So there's only two that we have learned. One is additional, one is condensation. So the additional, you will not see any of the carboxylic acid group or alcohol functional group present. No ester linkages, no amide linkages. So P is basically your addition formed by through addition. Q, if you see an ester linkage, it is going to be by condensation, right? So our answer here is B. Okay, question 39. This one you need a little bit of memory work in your learning outcome for macromolecules. So for man-made fibers, right, we don't include cling film and plastic bags. Okay, the rest are all okay. So the only one which has all three for man-made fibers is option C. Okay, so for question 40, which equation represents a redox reaction that remove combustion pollutants in the catalytic converter? Okay, so this question you can solve it by identifying the pollutants. So carbon monoxide and nitrogen monoxide, they are pollutants still. So the only one that doesn't have a pollutant is option C.